Hi and welcome back to Rock the JVM. I'm Daniel, and in this video I'm going to talk to you about idiomatic error handling in Scala. So this video will teach you a couple of techniques on how to handle errors in Scala in increasing order of difficulty. So this video is addressed to Scala developers of all levels. Now towards the end of this video we are going to be using the Cats library as well for some demonstration of the validated data structures. Now as a recommendation, as always, I'll recommend that you code with me in this video, and whenever you need to refresh your memory about these concepts, because there are going to be multiples, including some tips and tricks on how to think about error handling, just refer back to this video or to the blog version with the link in the description. So without further ado, let me get back to the code. And I have here an object with a main method just in case we need to test something and run this application. Now for context, I'm using Scala 2 here, but these concepts that I'm going to talk about are equally applicable to Scala 3, including the validated data structure that I'm going to talk about in the end, because it's such a critical data structure in Cats that is probably not going to change in the Cats version, that it will be native to Scala 3. Now, let's start with the straightforward way, or option 1, of throwing and catching exceptions in Scala. And the short story is that Scala runs on the JVM, so it can throw and catch exceptions just like Java. There's little more to say. This just leads to the first straightforward way of dealing with errors. Now, because Scala can throw and catch exceptions, naturally the try-catch-finally structures exist in Scala at the very language level. So if you want to throw and catch an exception in Scala, you would do something like this. You would do try, literally like this, like you would in Java, and then you would put in some dangerous code here. For example, I'm going to define a string called Scala as the string Scala, and I would try to access a character way outside the string boundaries. For example, I would try to return Scala car at 20, for example. And this would throw an out-of-bounds exception. Now, to protect ourselves from that, we would say catch, and then with a curly brace, we would catch and match various exceptions that we would like to handle. And this will be a pattern match expression. So I would say case E of type null pointer exception, and I would return the character Z, for example. And in case I get an exception of type runtime exception, I would return some other character like S. And then finally, we would add some code here to clean up resources. And the finally code does things. And I'm going to explain what that means shortly. So this is just code to clean up resources. For example, if you want to close some files or close some sockets or whatever, you would do that in the finally area. Now, I mentioned that the finally code does things because this whole try structure here is an expression, and thus it can be assigned to a value. So for example, if I call this expression magic car, I can assign that to the whole try expression. And the value of the try expression is normally the value of the code within the try block, and so it would return a car. But in case this code throws an exception, then the pattern match would influence the return type of this whole expression. So for example, here in the catch, I have two cases, each of which is returning a character. And so if the code in the try throws an exception, then the character in one of the catches will be returned as the value of this entire expression. Now, of course, if you don't match one of these exceptions, then that will throw a matcher, which will crash your entire JVM. All right. Now, I mentioned earlier that this structure up to the finally point will return a car, or it will return a value of a particular type inferred by the compiler. But the finally block, the finally structure, has no influence on the return type because the finally block only is used for side effects. So this is the very straightforward way of dealing with exceptions in Scala. And because this whole structure is an expression, we already have an advantage over Java. So I'm going to list some pros and cons here. So the fact that it's an expression makes things easier to understand for us because we can use this expression later in our code. However, this straightforward approach is rarely the recommended one for a few big reasons. First of all, it's very cumbersome and hard to read, particularly if the attempted code here in the danger zone is very big. Also, nesting such structures will be exponentially harder to debug and understand, so we generally try to avoid these. And for pure functional programmers, this finally block doing things outside of value computations might cause a small aneurysm. So we would like to avoid this kind of error handling in Scala, for which we have better versions. So let's try better. So idiomatic functional programming requires us to reason with code by thinking of every piece as an expression, hence something that reduces to a value. Therefore, we need to think exception handling in much the same way. And what I mean by that is that a successful computation as well as a failed computation are both regular acceptable values. So this is why we use Scala util try. So I'm going to import it because it's not automatically imported. So I'm going to say Scala util try. And I'm pretty sure you know about this try thing from your previous Scala experience. If you're a more beginner, it's worth peeking at how it looks like. So I'm going to command click or control click to see how it looks like. So we have an abstract class, try with the generic type t, it's covariant. And this extends a bunch of traits, we don't care about them. But what we do care about is what the subclasses of try are. So we have a case class called failure, which wraps an exception. And we have a case class called success, which wraps a regular value which didn't crash. And the way that we build try instances like these is to program against this try general abstract class. What do I mean by that? Let's say that I define a try instance as try applied to the argument 2. So this is essentially try.apply with the argument 2. There is an apply method in the companion of try. And this expression over here is a potentially dangerous expression that can throw an exception. And if that throws an exception, then this try apply method will return a failure. Otherwise, this will be a success. And in our case, this is a success wrapping the value 2. But if I define a try, let's call this a failure, and I'm going to type that as try string, for example, and I'm going to use try, and notice that I'm going to use the curly braces here because methods with a single argument can have this syntax. And I can use a code block here, and I can put in my danger zone. Let's call this here. And I'm going to copy that. And instead of try string, I'm going to use car because that's what the expression would return. And this would normally return a Scala car at 20, and the type of this block would be a car, and this would be a try car. But because this is a danger block, and this would normally throw an exception, this would be caught and wrapped in a failure. So this would be a failure with, as far as I remember, this is a string out of bounds exception. Now, why is this particular approach better than the previous one? I'm going to paste a bunch of pros over the previous approach here. So first of all, try deals with the computation and not the exception. So we can focus more on what we want, which is the value, instead of what we don't want, which is the particular exception that might be thrown away. And we have map, flat map, filter, and for comprehensions on these try data structures, much like we have on collections. So we can chain computations like these with map, flat map, filter, and for comprehensions, which make code easy, really easy to read. And I'm going to give a bunch of examples. And try also has some APIs for recovering from exceptions. So for example, if you want to handle a particular kind of exception and return a valid value after that, you can do a fail recover, and then you can recover the exception that you want to handle. So that's more flexible in terms of the exceptions that you want to catch, because it deals with the exceptions that you want, and the exceptions that you don't want are left behind. Also, try instances can be pattern matched, which is a huge bonus for both value and error handling in the same place. So let me give some examples. So we have a successful computation here. We have a failure. Let's show you how to modify successful computation. So I'm going to define a modified try as a try map underscore +2, for example. And this function will be applied to the result of this try, which will be a success of 4 in this case. There's also flat map and filter and other APIs for recovering in the face of various exceptions. So for example, I can define a val, let's call this a recovered failure, as a fail dot recover. And recover takes a partial function from various throwables that you might want to handle. And here you can handle case E, for example, of type runtime exception, and then you can return a value, for example, the character Z. So you can basically pick and choose which kind of exceptions you want to handle if you want to handle them at all. And you also have 4 comprehensions. For example, I can define a value, let's call this a chained computation, equals 4, and here I can do, for example, X in a try, and Y in a recovered failure. I can do a tuple X and Y. I can do yield, and then I can return that tuple. And because this is the middle of the video, this is my main point of advice. If you're just starting to use Scala, use this, that is, use try, until you never have to use the try-catch structure ever again. All right. So if you're just starting out, use this try until you never need anything else. And then move on to the next step, which is number 3 here. And the number 3 is based on the fact that try is based on the assumption that an exception is also a valid data structure. So fundamentally, an error in an application is also valid information. So we should treat it as such by manipulating this information into something useful. So in this way, we reduce the notion of an error to a value of any kind of type. So we can expand on this concept by thinking that an error, imagined this way, can have any type at all. This has historically been the case in computer science. Before exceptions in Java or on the JVM, there were error codes, and before error codes, there were error numbers. So errors meant different things in different contexts. All right. So this kind of concept in mind, we can then start to think about other data structures that are useful for error handling. So one example is either. So I'm going to import Scala util either. And again, I'm going to command click or control click on this thing. And either is an abstract class with 2 type arguments, either a type A or a type B. And either can wrap a value of type A, or it can wrap a value of type B. And the subclasses of either are, and let me scroll down, we have a left and a right case class. A left will wrap a value of type A, and a right will wrap a value of type B. So let me give some examples of either. Let's call this val a right of type either, let's call this string or int. All right, and I'm going to instantiate a right 22, for example. So this is an instance of the either type, either string or int. And in the exact same way, you can instantiate a left. Now, either is very similar to try in that one of the case classes is desirable and one of the cases is undesirable. And the convention is that the left side of an either is undesirable and the right side is desirable. So the value 22 is the quote-unquote success. And the left type string is the undesirable value, which can be thought of as an error. But notice that we can have any kind of type. We can have strings, we can have hints, we can actually have JVM throwables, you can have any type at all. And either can have pretty much the same API as try in the sense that you can have map, flat map, and filter. So for example, I can have a modified right, you can say a right dot map, and you can say underscore +1, and the map operates on the right type. So this will be a right 23, and if it's a left, then that will keep the same instance. And in much the same way, you have map, flat map, and filter can turn into a left if the predicate doesn't hold for that particular value, which is wrapped. All right. And because you have map, flat map, and filter, and with filter, you can have 4 comprehensions on eithers. So in that way, either is not really rocket science. So you can think of the right type as the desirable type and the left type as being undesirable, but it's also valuable in the sense that it can store information for your application, and it's widely used for error handling. And I'm going to paste some pros over the try type in the sense that the error type can be of any type at all. You can use strings, you can use throwables, you can use any type you like, and then you can also manipulate those data structures as you see fit. Now, other pros of either include what try already has, which is flat map, map, and filter, and 4 comprehensions, and APIs for converting between left and right and to other data structures such as options or try, and either can also be deconstructed with pattern matching in much the same way. All right, so that was either. Now I'm going to introduce the final technique for error handling in Scala by using the cats library. So for that, you will need to include the cats library definition in your project, and I'm going to go to build.sbt, and I have here under library dependencies, I have org type level cats core, and I'm using the version 2.2.0 at the time of this recording. Cool. Now, I'm going to use the data structure known as validated. Now, validated is a data structure used for data validation and error accumulation. And by the way, I teach this validated data structure in the CATS course, which you can check out by clicking in the link in the video description. And this CATS course will teach you everything that you need to know about the CATS library, including monoids and functors and semigroups and monads and reader-writer monads and state evaluation and data validation, traversal, Kleisleys, and all kinds of rocket science. So check out the CATS course in the video description. Anyway, so validated is used for error manipulation and accumulation, which is very, very important for things like forms, for example. Now, once you import that library that I showed you in build.sbt, the way that you would use validated would be to first import cats.data.validated. All right, now the way that you would build validated instances would be to use the various factory methods that come in the companion object of validated. So let me define, for example, a valid value, which is validated with two type arguments, much like either. The left-hand side is the error type, for example, string, and the right-hand side is the desirable value of your computation. So for example, I would say validated.valid, and I would use, say, 42 here. So this is the right desirable value here. If you want to define an invalid value, let's call this of type validated, again, string and int. This would be validated.invalid, and this would wrap an so-called error type. So for example, something went wrong. So this is the so-called left value. This is the error type. All right. Now, you can also check whether a condition is true, and the validated instance would be either a right or a left, that is a valid or invalid, depending on that condition. So I can say, for example, a test, which is of type validated of string and int, and I would say, for example, validated.cond, which is a condition factory method that takes a condition, let's say 42 bigger than 39, and if that condition is true, then you will return a valid instance wrapping the value, say 23. So if this condition is true, then this will be a valid, a right value wrapping 23. Otherwise, an error value, let's say the meaning of life is too small, for example. All right, so depending on that condition, validated.cond will return a valid or an invalid instance. Now, the important where validated shines is where error accumulation is required. So say, for example, that we have some conditions for a number. Let's call this validate positive, which takes a number int as an argument, and this will return a validated with list string as an error type. So you accumulate a list of errors and int on the desirable side. And I'm going to say validated.cond, and I would say that n must be greater than 0, and if so, I will wrap n. Otherwise, I will return a list with the string. Let me wrap the string inside. I'm going to say number must be positive. And let's say we have two more conditions of the same type. So I'm going to copy this method, and I'm going to paste it here. I'm going to say validate, let's call this validate small. And I want this number n that I receive as argument to be less than 100. And if it's not, then I'm going to return a list wrapping a string number must be smaller than 100. And again, I'm going to paste this method again. Let's say that this number n must be even as well, just to make the predicates super easy. So I'm going to say validate n mod 2 must be equal to 0. If so, then I'm going to wrap n in a valid instance. Otherwise, I'm going to return an error with a list number must be even. All right. Now, let's say that you have a number of conditions in your, say, business logic. Now, if you want to combine various errors for a number, let's say the number 3,333 is both bigger than 100 and it is also not even, and you want to surface both of these errors to your consumer. The way that you would do that would be something like this. I would define a method, let's call this validate, which takes an n as an argument, and this would be a validated with list, string, and int. And I would combine these three methods by saying validate positive with n, and then I would say combine, and I would pass in validate small with n, and combine with validate even with n. Now what combine does is it takes the instance of these validated instances, and if one of them is an error type, that is, it's an invalid wrapping a list, then all of these lists, all of the possible errors between these validated instances will be combined as given by a semigroup. And a semigroup is a data structure that will define how these data structures will be combined together. So for example, a semigroup for lists, for example, and a natural semigroup for combining lists would be to concatenate them. And so we would say, for example, import cats instances list underscore, and this will import the implicit semigroup of lists which combine them. And combination of lists means concatenations. So I'm going to say concatenates them. Now, a semigroup of numbers would normally add them. This is how you combine two numbers. The natural operation between numbers would be to add them. But we don't really want to add these numbers if all the conditions hold true. We want to have a different semigroup, that is a different combination function, which only keeps one of the numbers if you have a two-argument function. So I'm going to say implicit val, let's call this combine int max. And this is a semigroup of int, and semigroup belongs to the cats library. And you can define a semigroup by saying semigroup.instance, and I'm going to pass the argument type, and I'm going to pass a toarg function that returns a result, and I'm going to say math max, or just return the first argument. But I'm going to return math max just to return the bigger one of them. So in order to be able to combine multiple validated instances, you need two semigroups which can combine both the error type and the value type. Now, for the error type, we have this import cats instances list, which imports an implicit semigroup of lists, which concatenates them automatically. All right, so if you have two invalid instances of validated and you combine them together, you will return a single validated instance where the list is obtained by combining those two lists. So for the number 3,333, for these conditions, validate small and validate even will return two invalid instances, both wrapping a single list. And the number 3,333, wow, this is a mouthful to pronounce. This will return a validated invalid, so this will return an invalid, wrapping the list containing both errors. So the number must be smaller than 100, and the string number must be even. I don't know why I wrote that twice, but whatever, you understand the picture. So if you combine two validated instances applied to the number 3,333, then you would get the invalid with a single list wrapping both errors at once. This is where the value of validated is. You are able to combine the errors into one. So this is what this import does. Now, for the semigroup of int, you also need to be able to combine the valid instances if all the validateds are valid instances. And so if you try to combine three validated instances, you want to be able to combine the values that they might be wrapping. And you combine them with this semigroup, which I've defined as simply returning the bigger number of all of them. Now, because these three validated instances, if valid, they all contain the same number, it doesn't really matter what the semigroup does. It only matters that I've defined this implicitly in scope so that this expression can be even compiled. So for this magic number, 3,333, validate positive will return a valid containing 3333. all right? Now, the second validated will be an invalid with the list number must be smaller than 100. I'm going to abbreviate this for short. Now, for the third one, this will also be an invalid with the list that n must be even. Now, when you combine all of these, because you have at least one invalid which is combined, then the end result is going to be an invalid containing the list combining all the possible errors in this expression. So we'll have a list with n less than 100 and n must be even, or whatever those messages used to say. So the number must be smaller than 100 and number must be even. This is very, very useful when you want to test multiple conditions in the same piece of logic. For example, when you want to validate online forms. So validated is an instance of very powerful idiomatic error handling in Scala, and I've pasted a few pros and cons for validated. So validated is really powerful because it allows you to combine errors into one. You can also do that with try and with either, but with lots more headaches. Also, you have APIs to convert to and from try and either an option and other types within the Scala standard library. So validated is really flexible in this sense. Now, the only downside is that validated does not have the flat map method. In abstract terms, we say that validated is an applicative and not a monad, and the reasons for that are subtle, and I explain the details for that in the Cats course. But for this video, just knowing that there's no flat map should be enough. So in this video, you learned 4 different ways of handling errors in Scala in increasing order of complexity. I hope these techniques will be useful for you, in which case I'd really enjoy it if you click the like button for me and subscribe to the channel for more videos like this, and go ahead and follow me on Twitter and LinkedIn. I post fresh updates every single day. And check out the Cats course and the Rock the JVM blog and website. I have tons of content for you on Scala and Akka and Apache Spark and Cats and more. Until next time, I'm Daniel. Thanks for watching.